Recall that in the previous lecture, we obtained the divergence of electric field as rho r over epsilon 0. Also recall, before I started this mathematical treatment, I had talked about Helmholtz's theorem without proof that said that if I know a vector field on a boundary, or rather perpendicular component on a boundary, and if I know divergence and curl of this field, then I can calculate the field over the entire volume outside. So, this we have defined. Now, we want to understand the meaning of curl. I had written, when I had introduced this, curl of, let us again specialize to E as x component partial E z over partial y minus partial E y over partial z plus y component being partial with respect to z of E x minus partial E z partial x plus z component being partial E y partial x minus E x E y. How does this quantity come about and what does it mean? In this lecture, this is what we will try to understand, so that you get a feeling for a curl. Hopefully, by now you do have a feeling of divergence, diverging field, flux coming in, going out, that we have discussed. Let us understand the meaning of this. By in daily language, by curl you understand that something is going around, right. People have curly hair, or if there is a sink and water goes in it, it goes like this. So, the velocity field becomes curly, and we want to give a precise mathematical definition. So, suppose there is a vector field that is curling around. Let us take one particular line of this vector field and calculate the following integral. I will move along the line taking small segments delta L and calculate E on ith segment, multiply by delta L along the lines and add it, and make this path closed. Okay, so, although there may not be any field out here, but I will make this path closed, and let us see what does it come out to be. For simplicity, again I am going to take a rectangular path, let us say in the xy plane. So, please understand what I am doing. I am taking E at each point, taking this component along the path and multiplying by the small delta L and summing it all around, okay, which I can also write as what is called a line integral over a closed path E dot d L. This automatically gives the component of E along d L that I am taking. So, let us do it for this small path in the xy plane. Let us take the lowermost corner of this to be x y. Let this be x plus delta x, still at y, x plus delta x, y plus delta y, and x y plus delta y. And usually, when we do this going around a path, we take travelling direction to be positive if we are going counterclockwise. So, I am going to take it like this. This is x y, x plus delta x y, x plus delta x, y plus delta y, x y plus delta y. And let us calculate this integral over this entire path. So, here is my path made in a bigger way, and let me write the points again: x y, x plus delta x y, x plus delta x, y plus delta y, x y plus delta y. And let us calculate, traversing in a counterclockwise way, the sum E I delta L I. This is my path 1, 2, 3 and 4. Over 1, the value of E I delta L is going to be E x, and let us take this previous point here to be representing E x y delta x over 2. It is going to be E x plus delta x y delta y. It is not E x because now I am going in the y direction. So, it should be E y, which I can write as E y at x y delta y plus change in y with respect to x by the time I move delta x delta y. So, I have calculated over these two paths. Now, let us go to path number 3. I will again make it x y, x plus delta x y, x plus delta x y plus delta y, and x y plus delta y. Now, I am going to calculate over this path number 3. Notice that for path number 1, we had E x at x y delta x, path 1. When I calculate it over path 3, for each value of x, the corresponding value on path 3, the x value remains the same, the y value has changed by delta y. So, I am going to calculate for path 3, the E x is going to be E x x y plus partial E x over partial y delta y, right. For each x, y has definitely changed at each point, and we are taking the x value to be out here. Same thing for this. So, E dot d l over 3 is going to be, now notice that d l is in the negative x direction. So, this is going to be minus E x delta x, which comes out to be minus E x x y delta x minus partial E x by partial y delta y delta x. Similarly, over path 4, which is this path, this is x y plus delta y x y. Everything is over at point x. So, I am going to have E y x y delta y, and that is in the negative direction. So, minus, because now the displacement is the negative y direction, right. So, for each point here, the only difference is that x is reduced by delta x. So, it is at x and y, path 4. If I add all this together, 1, 2, 3, 4, if I add all this together for a moment, I will just show you what it looked like in path 1. This was path 3, which became this, path 2, and path 4 I have done. So, 1, 2, 3, 4. Let us calculate over path number 2. I had calculated over path 2. So, path 2 and path 1 and path 3 and path 4, when they are added together, path 2 was E y x y delta y plus partial E y partial x delta y. If I add all this together, what you are going to get is that the integral E dot d l over this entire path is going to come out to be partial E y over partial x delta y minus partial E x over partial y delta x delta y. You can go to back to the previous slides and see that all other terms cancel, which I am going to write as E y partial x minus partial E x partial y delta x delta y. What is delta x delta y? Delta x delta y is nothing but the area of this small rectangle. So, summation E dot d l over this rectangle is equal to partial E y partial x minus partial E x partial y, write x clearly, times this small area. Taking the right hand convention, that means if I curl my fingers around the path, the thumb gives me the direction of the area. So, if I go around like this, this is the x y plane, remember x and y, thumb gives the direction of area, I will take that convention, so that is the z direction. So, I can write this area, if I write it as a vector, as delta A z vector. You are not unfamiliar with the vector notation. So, earlier also when we were calculating divergence, we were taking area direction to be coming out of the volume. So, now I am going to use this convention that if I on a path, if I curl on a closed path, if I curl my fingers around the path, the thumb gives me the direction of the area. So, I can write this as delta A z, and this I am going to define as curl of E z component, z dot z. Okay, so, curl of E z component comes out to be partial E y over partial x minus partial E x over partial y. You can similarly calculate other components, and I will leave this as an exercise for you, and then the curl is defined as curl of E, which is symbolically x partial x plus y partial y plus z partial z, which we this is something which we had introduced earlier, cross product with E x x plus E y y plus E z z. I will first take the cross product of the unit vectors and then do the differential operation, and that will give you the curl.